Good morning, everybody. Today we're going to present this incredible tool that automates a lot of the very complex tasks that we have to conduct when we are fulfilling air quality studies and fulfilling regulations. Your host will be myself, Jesse T, and Mr. Michael Johnson. I'll be presenting the introduction, and Mr. Michael Johnson will cover the aspects on the real code running the actual AQMIS. Just give an overview why we need emissions inventory. I'm going to focus on emissions inventory, and then I'm going to show before you see the code running with my presentations, I'm going to see portions of AQMIS. So the big question is why we need emissions inventory. Well, we do it because regulations tell us to do it. But why regulations tell us to do it? Trend analysis, air quality, could be air quality modeling to satisfy regulations, a regional, local scale, impact assessments, and then human exposure. Because at the end of the day, those numbers that we do, they are all geared toward protecting human health. So the federal regulations, there are many, and in the US, I'll present here, every region will have its own set of requirements. But in the United States, there are federal regulations that are passed to states, and states are then delegated to supervise these regulations, a lot of them. So I have the State Implementation Plan, SIP. We need to do a whole bunch of studies with criteria and hazardous air pollutants. We have the National Air Toxics Assessments. We need to report things to TRI. We need to do photochemical studies. And in summary, these are the regulations in the US. Air emissions reporting requirements, national emissions inventory, TRIs, greenhouse gas reporting, and for those large corporations, the SEC. So the agenda today, once I did this overview, so go through the benefits of a system like this, and then we'll get examples with Mike showing how to use the system, and we have a question and answer period. So the benefits are very large. Here I'm just displaying to you some of the monitoring, mapping, locating things, and I will address these later on in the short presentation I'm making. So the benefits, we have regulatory agencies. It's unbelievable that in this day and age, people say, oh, we're here to protect the environment. And the first thing they do is cut budgets from regulatory agencies. And then consultants become benefits using a system like this. Everywhere we have been and used this, we are a software company. We team up with a environmental consulting company, and they then conduct the work and even run the system for facilities or for whole jurisdictions, from city to states to whole countries. And once they get in, they are there for the life of the system. So the companies and jurisdictions always hire them. So there's a tremendous cost reduction for facilities, and it automates the red tape. So the system is fully integrated, some major benefit. It automates the emissions inventory. And that by itself is already a big gain. In addition to that, each one of the modules are more or less independent. We can do the dispersion modeling for that. If I have the emissions inventory, I literally only press a button and it will run all the sources in a facility or the whole city or whole state or the whole country. And it will run all of them. And it's great because if we do monitoring, also an independent module, Ambient Monitor System, AMS, that's the monitor stations. We can see, doing the dispersion model, we can compare with the monitor and identify problems with the emissions inventory. So it is something that integration gives great benefits. So we identify if we're having problems. And we have identified people very often have a problem with units, and sometimes we see concentrations that are 1,000 times less than they're supposed to be because grams and kilograms were mixed up. The slide is not wide enough, so let's stretch it here so we can show all the things it can do. It conducts a full human health or ecological risk assessment from air toxics. This is important in a lot of places. It can do the whole permitting process for facilities, and if it is a regulatory agency, it can be receiving the request for a license or a permit to operate. It can do auditing and also generate reports and electronic reports. So in the US, for example, a lot of places then submit electronically directly to the US EPA, or if you are a city, you can report directly to the state. So let me give an overview. This is a dashboard where you can see here the monitoring. So you have different monitor stations indicated here and their concentrations. And you can see this curvy line because this concentration was so high. If we have plotted, these other ones would show so small, you wouldn't see it. So then we cut it here. The red line is the regulatory limit for CO for this jurisdiction. So we put this red line on all of them, and we know if it is exceeding or not. And these are no wind roses, these are pollution roses. And this gives great benefits. People are not using this in 99% of the cases because we know monitor stations are important. What people forget is we're not maximizing the use of the monitor station. In a certain case, and I won't reveal here, but I'll give an example. There was a refinery here, and the regulatory agency was investing all the efforts in forcing them to reduce emissions when the problem was not coming from the refinery, it was coming from a petrochemical plant here. So we can see very clearly, even without doing dispersion modeling, that this is blowing from, so it's blowing from here. So we give more value, and you see that we will add more value to monitor stations than the already good value it gives today. So just an example of clients using this type of system, the US EPA, the United Nations, and a lot of cement plants, pulp and paper, cities in the US, we can name a whole bunch. We'll just give some famous one like San Diego, Las Vegas, Reno, Chattanooga, just some examples. All the nuclear reactors in South Korea use the system, refineries, etc. Now, jurisdiction-wide studies are using the system. US EPA study from Houston to Lake Charles. This is 100 miles, 160 kilometers of the highest density of oil, gas, and petrochemical plants, pharmaceuticals, etc. The highest density. And we did a complete study and emissions, dispersion modeling, human health risk from all the chemicals, etc. Entire state of New Jersey, this is state of Minnesota. This state here is a case that I will show in the next slide. We did over 200,000 sources in the whole state, and with 2 million receptor points. Kuwait, Qatar, etc. And this is in Minnesota. State was investing a lot of efforts, and justifiably so from previous experience, but things have been changing. And today, the point sources, those monitors and other studies, they do not segregate the point from the area, from the road, on road, from non-road mobile, etc. It doesn't segregate. In our study, we can do that. We can separate who is causing the highest human health risk. And you can see here, point sources are very minimal compared to the roads. And you can see that the roads, the problem is they are not controlled, and the point sources, they are controlled, but when the plume hits the ground, they are very far from the point source and they're diluted. So the risks are not as high as on road. So everybody throughout this, the Minnesota presented to the US EPA. And if you see the studies from the USPA now is to reduce the impact from on-road mobile. So we can visualize things easily. Jurisdiction, this is a case in Brazil. And you can see that in the jurisdictions, the highest one for carbon monoxide is this one, particulate matter PM, PM10 is this one, etc. There are many types of dashboards, generated dashboards. This was an interesting case where they were focusing on the trucks, but the problem was vehicles, passenger vehicles. So thus they changed also the way they were doing their applications. There are a lot of standards. That's a problem throughout the world on greenhouse gases. The IPCC, the California standard, the Northeastern, Australia has one, Europe has another one, the list goes on and on. We meet all of them. So we have a way to calculate, we calculate differently. Emissions calculators, we have calculators to cover over 11,000 different processes that emits to the atmosphere. Crazy stuff like frying hamburgers, all the way to all processes on an entire refinery, airports, ports. We did a lot of ports, for example. And the list of vehicles and different manufacturing systems, etc. Dispersion model, the complete system. And here's a list of the type of models we cover. So AirMod, CalPath, WharfCam, CMAC, ChemX, etc. And the ambient monitor stations, I told you we add more value. Everybody sees this and reports on this. But why not add more value? So this is a pollution rule for SO2. We have 4 other chemicals. All the chemicals that you monitor, we have a different pollution rules. But look at this. We develop here a artificial intelligence system that will forecast what is the problem in the next 24 hours, hour by hour. And this adds a lot of value because these ozone studies, as an example, by the time you do all the emissions inventory, you do all the photochemical model and the reporting and have people running in the computers, use coughing up a lot of cash, and it will take a year or two to get this ready. We can do it in a matter of weeks, in a fraction of the cost. So we're presenting this in California, and they told us, oh, you cannot do Schefter because the photochemical model, and I know why it's failing there. There is a valley that is very narrow, and the grid is larger than the valley, so there is a problem there. You can't model that accurately. And they saw this, and they were shocked. So then they said, you cannot do Tranquility. Tranquility is doing even better. So it is forecasting 24 hours ahead. The orange is predicted 24 hours ahead, and blue is when it was measured. Then we compare what we forecast 24 hours before with what's being measured. And for 24-hour forecast, this is stunning. Produce AQI, current AQI, past AQI, and using the forecasting model, we can even predict a few hours ahead, like 24 hours ahead. Again, we do with AI, which is much faster, give very good results, or we can do with a photochemical model, your choice. You can prioritize what you need to investigate, complete human health risk assessment, permitting and compliance for the facility to get a permit, and for the regulatory agents to receive a permit request application. So it's forecasting using models. So you can see this, and we animate those. This on the left-hand side here is in Qatar. We run the whole country, all the industrial cities, and we run doing photochemical modeling there as well, and we get results there match pretty much the monitor stations. Extensive mapping, it's whatever you have will be due reference. Extensive reports with graphs covering a lot of things, and you can create your own reports yourself if you want, okay? Greenhouse gas reports, and now I'm back to you, Mr. Questions will be after the live demo. So now, Mr. Johnson, take control.
Thank you, Jesse. That was an incredible introduction to emissions inventory and the AQMIS system. So I would like to start by presenting a few of the high points that are in the AQMIS system, and then if time allows, we will speak to some deeper content in the system, such as how to do calculations and how to define them yourself. So a couple of things I would like to note is that AQMIS has a summary of dashboards that will give high-level feedback to not only participants in the inventory process and the environmental management process, but will also give enough data for people to make accurate and complete decisions. We also will talk a little bit about the emissions system, which manages the entire inventory, the monitoring module, which is a deeper version of the air monitoring that Jesse spoke to regarding either real-time or acquired data that can be then processed and managed by the system. Our air modeling system, ticketing for managing workflows to make sure that the emissions inventory and emissions management system proceeds on time, reporting, the GIS and integrated mapping, document management, and a few other items. Back to we will have the summaries are that we have facilities, so we can look at individual facilities, and we can see a quick summary of everything that's on the system. So we have the mapping that allows you to see where the facilities are. You can see the pollutants, the release points, and everything as a quick summary. If we click on something, for example, the release points, we can go ahead and look at the points of release on a technical basis. Now, if we come back, we can also see, for example, other facilities by doing a search, and we can pick them up and look at everything in our facility. So, for example, if we want to switch to this Chevron station, we can see where it's located. We can see it on the map. We can also choose to change the base layer so that we don't need to use kind of this Rand McNally driving map, but we can also see it in a satellite feed like you would in Google Earth. Excuse me. For AQI and monitoring, we also have the ability to compute the air quality index. Not only do we implement the US standards, but we support the Canadian and the European standards for AQI. You note that we give a map and a location so you can see visually where the station is located. If there's an air quality index health effect, we will compute that. We will tell you the compound of concern, such as CO in this case. And we will give advice based on the regulatory requirements for EPA. So it'll tell you who should be concerned and what should I do as far as activity. Not only can this be presented internal to the agency, but can also be built into a public access portal so that the public can be informed of what's going on in the monitoring network. If we scroll down a little bit further, we can see that there are better AQI, so we can see at other stations where there might be good effects. We can see what the health effects are based on what pollutants we're measuring. So we can see we're getting good NO2, good O3. We can see day-to-day charting. So this allows us to see what has happened and how the air quality has been trending. And we can also see the data in a tabular form. Excuse me. As far as other components, we can look at air modeling. So we can see summaries for values that have already been completed. So we can see the scenario. So if an expert modeler has already created the model, it's now able to be reviewed and summarized by the entire team. This is extremely handy for when we are now in a work from home or remote working scenarios. You can share the results without having to do complex mailings. You can see the values as needed. So you can see, for example, the individual compound. You can see how it presents on the map as a contour. You can see an individual other compound, so we can see the sources of benzene as they emitted, and we can see that there are multiple sources geographically dispersed. We can see how toluene is impacting in this scenario, so we can see again, as we included multiple scenarios and multiple sources, we can see those. So now I would just like to also show some things for ticketing so we can see tracking of things that we may need to do. So we can see that if we have to do a site survey, we can see who's responsible. We can see who needs to report emissions, who needs to run a source test, who's responsible, and other things such as a modeling study and who's completed that step. We can see what's assigned, and we can see anything that's overdue as far as tickets that still need to be completed for our work this year. Excuse me. Central to that, we also have a complete map. So we are able to look at the full study area. We can see points not only related to the facilities, but we can include the release points by showing where they're located. We can turn them on and off. Again, we can control the base layer as needed, and we can bring in modeling results, such as we can do contours for different modeling scenarios. You'll note that not only did we, like we had on the dashboard, we can see a color ramp showing the levels of concern, but we can show it here in a nice map that allows us, without needing complex or integrating, again, with complicated scripts going to ArcGIS, it's built in. You don't need to do quite a lot. On the reporting side, of course, there are built-in reports that can be run. So we can do, for example, pollutant totals from our inventory once we've compiled it. We can choose the class of pollutants, such as criteria pollutants. We can highlight the pollutants we want to get a report for just by clicking. We can choose next. We can see the type of period, such as annual, since that's what our inventory is based on. I'm going to finish. Excuse me. You'll see that we have a report ready to print. We can export these not only into PDF, So if we want to print this and mail it, we can send it to Excel for further processing, or we can include it in Microsoft Word. So for example, if I export to Microsoft Excel and I open the document, you'll see that the report, as exported into Excel, is the same as it is in the print file. You note that we can even change values so that if we want to round this, we can say 493. For example, to reduce the complexity, you can see that these are live values, so I can just format these cells if I wish. And this just gives you a lot of value add because you don't have to struggle or do a lot of work to get something ready to report on. So we can say number and apply, and then you can see that it is actually live data. With that, I'm going to return to the dashboard, and I will open the floor up for questions and answers.
Thank you, Mike, for this very well presented walk through AQMIS. I have a question here, which wants to know if this is can be translated to other languages. I gave an example there of the one that was with the greenhouse gases. That one was in Portuguese. We have this in French, and we have this in Spanish. It can be translated to any language. For another question, asking for the AQMIS, how many stations this can, or the monitoring stations, how many can be employed, as if there is a limit. There is no limit. Usually the limit is the number on your budget to buy stations, because we can put 1 million easily, 1 million stations. Problem is nobody's going to buy 1 million stations. So there is no limit to the number of stations. I have another question to ask, what is a good photochemical model to use with AQMIS? Look, they're all good. We have a bias towards using WRF-Chem or ChemX. That's because we deal with the development team of WRF-Chem. So WRF does the wind calculations and forecasts. Let's say we get satellite data, etc. But there is also a version called WRF-Chem. We use that, for example, for dust, blowing dust. We use that in the Middle East, for example. And we also have a preference for ski chem, which is ski path with chemistry. And that is very good because we can trace exactly back to the source that is causing the most contribution to that ozone level. I have another one that says, the map include African countries too? Yes, we have both satellite and street level maps. Another question is, can the air quality modeling source be output? Yes, it can. And we can generate reports with the sources, and we can download the sources in Excel, we can download even the measurements in the monitor in Excel. Can the software come with any manufacturer for the monitoring? We have dozens of manufacturing that we connect, but we can create new ones if you have different ones. Can you present the emission estimation tool, how it works? Yes. We can do this. Let me answer another question. Is the emission inventory built in, or we have to input the emissions manually? The calculators, which is the tough part, we have the only set of calculation methods that was validated by the US EPA. We provide the solution to the tribes in the United States, and the US EPA validated then the calculation methods, every single one, because it was under a contract with the US EPA to provide that, and then they are validated by the US EPA. Approved and validated is impossible to find by the US EPA. We're the only ones. So the calculation methods is the difficult part. You have to enter what we call throughputs. So for example, a simple one. Let's say you're burning a fuel oil. Then you need to tell us how many liters, thousands of liters, or how many gallons of fuel oil you were burning in the period that you want to do the calculations for. Then we compute the CO, CO2, the SO2, and all the other calculations. There are more complex ones, but this is just an example. I've been asked here how we get additional information in AQMIS. And it is, you can send email to AQMIS@weblakes.com, and we can send you more information. Now, there's a website, yes, it's on weblakes.com/AQMIS. So let me even put it here. HTTPS. And you can get more information there as well. Now, for the one that asks for more, we are more or less done because it's the 10:30. The one that asks for us to give a demo, we can present the demo. Let me see if we still have people here. Yes. So we can present the demo. Michael Jones can present how to use the emissions, and you can create even your calculator. Another question I have here, I'll answer right away, is can we change the emissions factor? Yes, absolutely. Everywhere we go, there has a different emissions factor in the globe. We go in different places in the globe, there will be different emissions factors. And you can, if you measure your own and you want your own emission factors, you can. The system also keep track of all the changes that were injected in the system. Absolutely, if you change an emission factor for SO2 for this process in this source, we keep track of that. Later on, you can find out the change from this one on this day to that one. You can even add explanations why. And since you have to enter your ID and password, we even know who changed, date, and the reasons. Okay. Mr. Johnson, you can take control and show just briefly how to use the emission system, or navigate a little bit, and we can give further explanations later. Yes.
Sure, I can do that. I just want to show that in the emissions, you'll note that we are
maximizing the screen because it's small.
As far as I can tell, that should be large enough.
Okay, yes, that's good. Thank you.
Okay. So you'll note that we in the inventory we take point sources. We have other beyond point sources, so we have non-point, non-road, on-road, fire events, and biogenics as needed. One of the things was asked about were the calculators, so I will show. In the calculators, I'll show how we create and edit individual calculators. So I kind of prepared this EQ02, which is a demo equation, and we'll just show a few of the key points of it. So in the calculator, we give the name.
Just to clarify to everybody, he's showing how you can create your own calculator, but there are thousands and thousands of calculators there, okay?
Right. So here you'll see that this is a user-defined calculation method, and you'll see that it has a simple equation, which is really just the EF times throughput. So anyone who is familiar with AP42 and the introductory chapter has seen these two terms. So it's just the emission factor for the amount of emissions per the unit of throughput. And you'll note that we have the throughput value. You'll see the emission factor here as a input variable, the throughput value. And I've just defined a simple compound such as copper, which gives it in kilograms per kg of throughput. So you can see all of this information. Now, once we have defined this, I can run this calculator, and you can see in the calculation, I can set the inputs. So I can set the throughput to say 1,000 or 10,000. And when I go ahead and click next, it will give me on the spot an input. So this is quite handy for doing, when you're defining a new calculation, for you to do a validation and verification sheet, and you can check that your math is correct based on the independent calculation with what's in the system. So this is how it's quite easy to set up the calculation method on your own. So if you're comfortable with programming, say, building a spreadsheet such as Excel, this will become quite natural to you as far as setting up the cells and making the calculation. Now, if we want to look at actually executing other types of calculators, I can show that too. So for example, in the demonstration facility, I can come and I can choose the type of calculation. So instead of using the user-defined, I'm going to show how we set up a pre-built natural gas combustion calculation. So I can click next. And you can see that it will tell us all about it from AP42. So it'll tell us the section. It'll give us a nice description of the calculation method, how it came to be, and the reference in the AP42 documents. When I click next, we can see the throughputs that we need. We can choose either metric or US standard pounds for the output. We can choose the kind of combustion, so we can see the type of boiler that we're talking about. And then we can say the amount of gas fired, the heating value that we used, if we have any kind of control such as a low NOx burner, and if we know the sulfur content. Once I've filled this out, I can click next, and it will give me my complete estimates for emissions. So we can see the pollutants, we can see the actual emissions in tons, and we can see the rating. So we can see whether we have good or bad values from the calculation. And then if we need or we're concerned about some of these compounds, we can then recommend them for a source test because the rating is not as great as we would hope for as far as the emissions. And then once we're finished, we can just go to see the imported emissions and click finish. And there we have just added these calculated emissions into our inventory. And so now we can see that for this facility, we can see all of the compounds that are filled out. And it's pretty much that straightforward as far as building out your emissions inventory each and every time. Okay, and I'll leave that back to you, Doug.
Let's say that you did in 1 year all the entry, calculated the emissions. Next year, all you have to do is to show the new throughputs. Throughputs again is the amount of fuel or amount of products you're processing, and then it will just recalculate everything for you. If you have multiple years, it will show trend analysis as well, seeing if it is going down or up for each one of the chemicals you are investigating. And I can see we ran out of questions. So thank you very much, and you guys stayed a little longer than we had planned. We appreciate that very much. If you have any questions, email us at aqmis@weblakes.com. You can even talk with Mr. Brian Matthews and can clarify them to you. I hope to see you soon.